So an antibiotic is added to a bacteria culture. The function n of t represents the count of the bacteria alive with respect to time in seconds in an exponential manner. I think that's the number of bacteria. They don't, yeah, represents the count of bacteria alive. Okay. So it says, what is the asymptote and the y-intercept? So this one is kind of easy. Well, let's figure it out. Well, the y-intercept occurs when t equals 0, right? So we could do this mathematically, but in other words, we don't need to look at the graph, but we can. So I think that it crosses at 0, 8,000, right? But I can verify that. I could say n of 0 is equal to 8,000. I'm just going to use this function and then plug in t for 0. So I got 0.79, that's the decay factor, raised to the t, but instead of putting in t, I'm going to plug in 0. So when I do that, boy, that's not a very good 0. It's so hard to draw on this thing sometimes. All right, so this whole thing, anything raised to the 0 is the same as 1. So I've got n to the 0 is equal to 8,000. And then, like I said, this whole thing is equal to 1. Well, what's 8,000 times 1? Just 8,000. So this tells me that this does cross at 0, 8,000. Right? We get the 0 from here and get the 8,000 from here. So now that's what we call the y-intercept. So this is the y-intercept. Now, the last thing they want is the behavior, the asymptotic behavior. Well, the asymptote there's a P in here, asymptote. I always say it's asymptote. I always say asymptote. Occurs when y equals the lowest value you could get for y. And that would just be 0 because you want to keep going till there are 0 bacteria left. Does that make sense? Oh, now it's going to take forever to stop. Hello, this is Mr. Adams. Yeah. Yep, we just finished our notes. Bye.